work on the hardware. They wrote load and store instructions to get stuff in and out of memory, and they played about with bits and bytes and stuff. You could do pretty good work with that, but it was very specialized. Then they figured out that you could build languages fit for humans for specific areas. Like they built Fortran for engineers and scientists, and they built COBOL for businessmen. And then in the mid-60s, a bunch of Norwegians, mostly Ole Johan Dahl and Christen Nygaard, thought, why can't we get a language that sort of is fit for humans for all domains, not just linear algebra and business? And they built something called Simula. And that's where they introduced the class as the thing you have in the program to represent a concept in your application world. So if you're a mathematician, the matrix will become a class. If you're a businessman, a personnel record might become a class. In telecommunications, a dial buffer might become a class. You can represent just about anything as a class. And they went a little bit further and represented relationships between classes. Any hierarchical relationship could be done as a bunch of classes. So you could say that a fire engine is a kind of a truck, which is a kind of a car, which is a kind of a vehicle, and organize things like that. This became known as object-oriented programming, or also in some variants of it as data abstraction. And my idea was very simple, to take the ideas from Simula for general abstraction for the benefit of sort of humans, representing things so that humans could get it, with low-level stuff, which at that time was the best language for that was C, which was done at Bell Labs by Dennis Ritchie. And take those two ideas and bring them together so that you could do high-level abstraction, but efficiently enough and close enough to the hardware for really demanding computing tasks. And that was where I came in. And so C++ has classes like Simula, but they run as fast as C code. So the combination becomes very useful.